Okay, today's lesson we're going to be solving quadratic equations by completing the square, which is just a special method that really has a lot of applications as you get into higher level math. So the first thing we want to do is take a look at how we solve with the square root property, which we did earlier in the year. Anytime you have something squared, the opposite of squaring, the opposite of that exponent, is to square root. And so we see with this x squared, to solve this, it says x squared equals 81. We can square root both sides. And you have to remember, whenever you square root, you have to put that plus or minus because there's two possible answers. X equals, now the square root of 81 is 9 or negative 9. Sometimes people write it as x equals plus or minus 9. So that's the easy one. It's basically just x squared equals plus or minus radical 81. Or 81, and then you square root. For problem number 2, same idea. We've got this square right here. So to undo that square, we need to square root. And if we square root one side, we have to square root the other. You put your plus or minus. You get x plus 6 equals plus or minus the square root of 7. 7 is a prime number, doesn't have any perfect squares as factors, so we can leave it like that. But we're not done because we need to get rid of this plus 6. So I subtract 6 from both sides, and you end up with x equals negative 6 plus or minus the square root of 7. Last problem over here for problem number 3. In order to solve by square roots, you need to get the part that's squared by itself. So I'm going to start by moving the 3 to the right side of the equation. That's going to give me 49x squared equals 3. Now I can divide by 49 on both sides. X squared equals 3 over 49. At this point I can square root, put your plus or minus. Nice part about this is you get x on the left, the square root of x squared is x. On the right hand side I can split that up and I can have this as the same as the radical 3 over the square root of 49, which gives me, don't forget that about that plus or minus, radical 3 over 7. So there's your final answer on that guy. So that's how you solve by square roots. And that's going to come into play later on after we do all this method of completing the square. When we solve by completing the square, we're trying to rewrite equations so we can solve them by square roots. So if you can see, I've got some perfect square trinomials here, and you'll see what I mean. We can factor this, right? Now, our normal method of factoring, we look at this last number, we say, what are the factors of 4 that add up to the middle numbers, right? Factors of the last number that add up to the middle number. And if we were just doing it with that regard, the square root of 4, or the two numbers that multiply to give you 4, are 2 times 2, which would give you x plus 2 times x plus 2. We can write that as x plus 2 squared, which is similar to what we had up here with example 2 above, where you have something squared, but it's a parentheses. Same idea here. I've got a positive 9, and when I add them together, the factors of 9 that add up to negative 6 are going to be x minus 3 times x minus 3. And some people already know, hey, it's the same number twice. Negative 3 times negative 3 gives me positive 9, negative 3 plus negative 6, so you can write it like that. And over here, let's just skip the step. They multiply to 25, and they add up to 10. That's going to be 5 and 5. So I can just say x plus 5 squared. That's what we're trying to do. These are perfect square trinomials. They can be written like that. So now the question is, how can I create a perfect square trinomial, right? How can I look at this 4? What makes this work? Why is 4 and 4 a perfect square trinomial? How does 9 and 6 or 25 and 5? And so what we need to come up with is a number that we can put into the last spot. We can put it into the last spot so that it's a perfect square trinomial. Well, this actually becomes pretty easy for us. We can take this middle number. We need two numbers that are going to add to 8, and they have to be the same number, right? Well, 4 plus 4 gives me 8. So 4 times 4 is 16. 10 plus 10 gives me 20. 10 times 10 is 100. Negative 1, this is tough. Negative 1 plus negative 1 gives me negative 2. Negative 1 times negative 1 is just a positive 1. Here is the rule. You take the middle number. So if we think about this, if we've got ax squared plus bx plus c, well, we actually don't even want that a. In each of these cases, the a is 1, so let's just get rid of it. If we just have x squared plus bx plus c, how does the 8 relate to the 16? how does the 20 relate to the 100, and how does the negative 2 relate to the 1? And here's what you do. You cut it, and you square it. That's what I like to say. You cut it, you square it. You cut it, you square it. When I say you cut it, you take the b value, you cut it in half. It's b over 2 squared. The c value we want is the middle value cut in half and squared. All right? Cut it and square it. Cut it and square it. Let's take a look at some more examples here. Use a rule to complete the following squares. So I'm going to take negative 12, I cut it in half, that gives me negative 6, and if I take negative 6 and square, that gives me 36. But check this out. The answer here, when I write it as a perfect square, x minus 6. We'll notice that this minus 6 is the same as the number when we cut it in half, the b over 2. Half of 5, that's 5 over 2. Now that's not a perfect number. I'm just going to square it. That's going to give me 25 over 4. Multiply top and bottom. But inside here, I can just say 5 over 2. If I take 1/2, oh boy, and then I divide that by 2 and square it, yikes. 1/2 divided by 2 is the same as 1 over 4 squared, which is going to give me 1 over 16 to get the perfect square. And inside here, it's x plus 1/4. Now notice if this value is a negative, like it was on letter A, it's a minus sign inside. If it's a positive, it's a plus sign inside, okay? I'm just going to undo that because we don't need that holding us up here. All right, let's keep moving on. Solving the quadratic equation by completing the square. Follow the steps to solve the quadratic by completing the squares. First, write the equation in the form ax squared plus bx equals c. So I'm going to take this 3x squared, this 3x squared minus 24x, and I'm going to, oh boy, I am going to move, I'm going to add 27 to both sides, so that's going to equal 27. So that's step 1, 3x squared minus 22x equals 27. Divide both sides by a, so you have an equation of the form x squared plus dx equals k. So I'm going to divide everything. Oh, I messed that up here. Hold on. This should be a 24 in there. Sorry about that. That's 24x. All right. So I'm going to divide everything by a. So I'm going to divide by 3 here, divide by 3 here, and 3 here. Make sure you divide everything by that a value. That'll give me x squared minus 8x equals 9. Use the following steps to write one side as a perfect square. So we're going to have to add those blanks. So right here I'm going to say x squared minus 8x plus blank equals 9 plus blank. And now let's fill in the blank by finding the perfect square. Half of negative 8 is negative 4. Negative 4 squared gives me a positive 16. If I add 16 on the left, I better add 16 on the right. That's going to give me x, when I factor the left side, x minus 4 squared equals 25. Now we can solve this because this right here is just like we had. Let me pop over here. This is just like problem number 2, right? We had x plus 6 squared equals 7. Here we've got x minus 4 squared equals 25. We can just solve it by square root on the left, square root on the right. Put your plus or minus. X minus 4 equals plus or minus 5. Let's add 4 to the other side. X equals 4 plus or minus 5. When I take the high road, I get 4 plus 5 is 9. Or take the low road, 4 minus 5 gives me negative 1. 2 different answers. So that's a quick little look at solving by completing the square. There is a practice worksheet for you to try, just 6 problems. Okay, when you do this, make sure you really go back and look at this example we had, our last example. You got to get the x squared, the x parts by themselves, right? We want the x's on the left and the numbers on the right. And then make sure you divide by the a term if there is one. If I looked at that worksheet, it doesn't look like 1, 2, 3, 4, 5. None of them even have the a term, so you'll be able to skip that part. And then you just need to make sure you complete the square, right? And you complete the square by cutting and squaring. Don't forget, you're going to add blanks on both sides. I like to add them on both sides because that reminds me that I need to put something into both sides. Hey, that's solving by completing the square. We'll see that again when we try to find the center of circles on the next lesson we do. Good luck. We'll get some practice in class.